Good afternoon, everyone. I hope you all are well and safe at your home. I am Vandana Sharma, Chemistry Faculty in DPS Khanna. You all are welcome to Subject Enrichment classes. In this class, we will prepare you for NEET and JEE exam. Now, what is NEET and JEE exam? NEET is a medical entrance examination which is conducted by NTA, that is National Testing Agency, for admission to MBBS, BDS and other medical courses. And JEE is an engineering entrance exam which is conducted for admission to various engineering colleges in India. So, here I try to show you that duration of exam for NEET is 3 hours and total number of questions are 180. It divided into 3 sections: physics, chemistry and bio. Physics and chemistry 45 questions you have to attempt and bio 90 questions, and marking scheme for these questions are +4 mark for each correct answer, and there is negative marking also, that is -1 for each wrong answer and 0 mark for each unanswered questions. Means you have to take care for every correct answer you will get +4 marks, and for every incorrect answer you there is -1 mark, means negative marking is there, and total paper is of 720 marks. And for JEE it will conduct in 2 exams, that is JEE main and JEE advance. So duration of exam is 3 hours. Total number of questions are 75. It will also divided into physics, chemistry and maths portion. Physics 25 questions, chemistry 25 and maths also 25. Its marking scheme is the same as for NEET, but in this for chemistry and for physics and for maths 20 questions are MCQ based and 5 are subjective questions. That rest detail you can ask freely from Jitinder sir. He will guide you more. So without delaying, we're going to start with chapter 3 of chemistry, that is classification of elements and periodicity in properties. You have already done it with the Gaurav sir. He has discussed few topics of this. I'll discuss just in brief those topics, then we'll continue. First of all, why there is need for classification of elements. So till 1800 only 31 elements were discovered. Then in 1865 63 elements, and till 2016 118 elements. So to study this much large number of elements, if they are not arranged in a sequence, they are not arranged in a particular manner, then it's very difficult to study them. So that's why there is need to classify all the elements. And as per IUPAC, now there are currently 2 million inorganic compounds and 18 million organic compounds. So an arrangement. Now what do you mean by periodic table? Periodic table is an arrangement of elements in which similar properties of elements were arranged in a tabular form, which arises periodic table. And because of formation of periodic table, it provided a way to study the chemistry in a much simpler way. I don't have whiteboard at my home during this lockdown period, so that's why I have to do work on these A4 sheets like this. I hope it will clear to you. So first of all, we'll start with history of periodic table. So first technical periodic table was given by de Bernier. Before de Bernier, one scientist was there, that is Lavoisier. He classified elements only into 2 types, that is metals and non-metals. So de Bernier have given its periodic table in 1827, but Lavoisier, he has given 100 years before of this de Bernier. So you can say that this de Bernier law of triads, that is the first technical law for periodic table. What de Bernier does, he has made elements, they have fitted elements into triads. Triads means elements in the group of 3. You have done it in your 10th standard also, in last chapter of chemistry, that is classification of elements. You have read about Daubernier. So I have written here this E1, E2 and E3. They are the elements which are present in triad, and M1, M2, M3 are their atomic masses. That what he told about these, if this one is the first triad, first lithium, then sodium, then potassium, and if we'll take arithmetic mean of atomic mass of lithium and potassium, means if we'll sum up lithium and potassium atomic mass and divide it by 2, that's what I have written here, that M2, that is the atomic mass of middle element, is equal to M1 plus M3, that is atomic mass of first element, and M3 is atomic mass of third element. Then divide it by 2, then we'll get 23, which is the atomic mass of middle element. So that is Daubernier triad. Ki if we have arranged elements, or he has arranged elements in the group of 3 elements, and he told that if we'll sum up atomic mass of first and third elements and take their arithmetic mean, so that arithmetic mean will be the atomic mass of middle element. So in second triad, you can see that calcium, strontium and barium, these 2 atomic masses, if we'll take their arithmetic mean, that is equal to atomic mass of strontium. Same way in third triad, that chlorine, bromine, iodine. So now here is one very important question arises, that how many triads were known at that time? That 4 triads, and fourth one is this one, sulfur, selenium and tellurium. So this is all about Daubernier triads. Now why it gets failed? Because it was limited to few elements and it's applicable to only 12 elements, but at that time 31 elements was present. So in the sum of the triads, all the 3 elements is possesses same atomic masses. You can see here iron, cobalt and nickel, ruhenium, rhodium and palladium, they have nearly same atomic masses, similar osmium, iridium and platinum. So that's why all known elements he can't arrange in a tabular manner. That's why he was failed. Next comes to Newland law of octaves. He told that 8 element properties are similar to the first one, means that the node of sa, re, ga, ma, pa, dha, ni, sa, get first and 8th element properties are similar. Now what are its demerits, or I have written here, keep in mind, these are the important points which you need to learn, that it's worked only for lighter elements till calcium only, and discovery of noble gases failed this because at that time helium and argon were present, but Newland have nowhere included them in his periodic table, and it's not valid for heavier elements. As for oxygen and iron, he was placed in the same group having vastly different properties, and moreover he was not able to explain the reason for periodicity. You can see here I have tried to show that oxygen, sulfur and then iron, they are placed in a same group. I think this iron is not clear, so I'll dark it. It is Fe, that is oxygen, and here is sulfur. So this is all about Newland law of octave. Thank you. Next are Lothar-Meyer curves. Lothar-Meyer explained that physical properties of elements are periodic function of their atomic masses. He has plotted atomic volume versus atomic mass, and he explained that elements which having the similar properties, they occupy similar positions on the curve. You can see here all the elements which having similar properties, like alkali metals, they have occupy the position at the top, like first lithium, then sodium, potassium, rubidium and cesium. They occupy the maximum volume and they occupy peaks. This shows that their properties are almost similar. That's why they occupy the same position at the curve. Second comes as the halogens. Halogen occupy ascending positions on the curve, that is fluorine, then chlorine, here is bromine, here is iodine, means ascending positions they are occupied by halogens. And alkaline earth metals, they are descending positions on the curve, like magnesium, then calcium, then strontium, barium, they occupy descending position on the curve. And transition metals, they are transition metals which are have here, they occupy the minima of the curve. I have tried to explain in this way also. I have shown this circular form, that is alkali metal, they occupy the largest position and that are present at maxima of the curve. With this circle, with this square, I have tried to show halogens which occupy ascending position of the curve. Then alkaline earth metals, they I have shown with the crossed, they occupy descending position on the curve. And transition elements, these are transition elements whose occupy minima of the curve. But why Lothar-Meyer curve failed? Because it was an ideal classification, but it's difficult to learn all the positions which are occupied by these elements, and he could not determine the position of all the known elements, and he also cannot explain the cause of periodicity. Periodicity we'll learn later on. What do you mean by periodicity? So this is all about Lothar-Meyer curves. Then after that, Mendeleev's comes. What Mendeleev periodic table has told, that physical and chemical properties are periodic function of their atomic masses. He has explained periodic table on the basis of their masses. Mendeleev periodic table divided into 7 rows, which is called as periods, and 9 columns, which are called as groups. Each column is further subdivided into 2 parts, that is, first of all it is 1 to 7 groups, then 8th group, then 0 group. 1 to 7 groups, they are divided into 2 subgroups, A and B. And 8th one, he has arranged 3 elements each in group 8 and 0 group for inert gases or noble gases, but he was not explained further till 0 group. Means he was unable to explain much about 0 group for noble gases. And in your NCERT book, you can see easily, this one is the Mendeleev periodic table, in which there are 0 to 8 groups are present, and each group is further divided into subgroup A and B. Here they have shown you elements like this way, means I have tried to show you this beryllium and magnesium. Beryllium is present in subgroup A and this one is B. Calcium A, zinc B, strontium A, cadmium B, and so on. And what is present in group 8, I have written here ABC. That means 3 elements are present in group 8. You can see here iron, cobalt, nickel, ruthenium, rhodium, and palladium. Then osmium, iridium, and platinum. So he has explained this 8th group into further 3 elements. He has taken 3 elements each in 8th group. So he got success. What are the merits of Mendeleev's periodic table? Its classification of elements were based upon properties of elements, and he left gaps in his periodic table also. He means in future elements were discovered and they got that placed which he has left, and actually it happens he has left some spaces and he had given them name as Ica. Means if he has left place for Ica boron, here its element comes which name is scandium. For Ica silicon, next comes germanium. For Ica aluminium, here comes gallium. So it was his big success that all the elements got that places which he has left. And he determined and corrected the doubtful atomic weights also. I have written here beryllium, earlier atomic mass, and then corrected was Earlier its atomic weight was 13.5 and valency is 3, but he has corrected his atomic weight. Now it's 9.01 and its valency is 2. So that was all about merits of Mendeleev. Now why it fails, that demerits of Mendeleev periodic table. He was unable to explain hydrogen, that he was not able to explain where hydrogen exactly placed, and he is unable to explain the anomalous pair. Anomalous means why first element properties are different from the rest ones, and where is the lanthanides and actinides placed in his periodic table. He has no idea for that. And coinage metals means those metals which are used for preparing coins, like silver, gold and copper, silver, gold, platinum. They were placed with alkali metals, although their properties are entirely different from alkali metals. But you can see here they have got placed with alkali metal, lithium, potassium, rubidium, cesium. They are alkali metals, but in his group 1 they have kept here copper, silver and gold, which are coinage metals. So coinage metals placed along with alkali metals, and he has no explanation for periodicity of properties, and he has not explained about noble gases. Although he has given place for noble gases, but he was not able to explain much about these inert gases. So this is all about Mendeleev's periodic table.